So basically, what's this concept of an L1 that I've been talking about and that we talk about extensively inside of the token economics paper? So the L1 is basically a sort of standardization of what we think of as like a base layer, like Bitcoin, Ethereum, and what other kind of token is running its own live network, as opposed to like an ERC20 or something that's like a L2 token. And so that's sort of where that comes from. And so at least from the DAG perspective, what we are able to do, which sort of enables, not sort of, it does enable the L0 layer, is to organize this data topologically such that it gives us a sort of smooth time. And that basically allows us to reason about the state of our network and different data types that are, as we sort of showed before, can be normalized. And so this normalization occurs using Shannon entropy and user-defined data types, such that we can understand disorder in how nodes perform and make decisions based upon some sort of self-awareness of the recent previous state of the network. And so, yeah, that's sort of the TLDR there. And so I'm going to show you guys actually something really cool, which is, right hot off the press, basically an implementation of our L1, the DAG L1, operating directly on top of streams, which is pretty dope because that basically means that as opposed to like before with a linear blockchain, basically like taking all these transactions, buffering them inside of a mempool, we can just stream them with only a small margin of buffering or marshalling that needs to happen in order for us to reorganize or sort or join them into the correct, intermediate form, and just continue that down into a final destination. So this completely changes the game in terms of how do we actually perform consensus from being some kind of really big esoteric special thing to really just being a, like a uniform API call, series of API calls.